It's Wednesday, first homework assignment. We're hitting the ground running here. This is really the point of this assignment is to lay the groundwork for the rest of the assignments so that you can be, let's see, what's going on here? Hello? Testing. Okay. Okay, so this assignment should be laying the groundwork for future assignments. So the first one should be super easy. This is something that literally everyone can do. Sign up for the course mailing list. Super easy. Some of you have already done this. Look at you, you're already ahead. Second part is Bandit. So, you know what, I'm just not gonna use this mic. The second part is Bandit. So for Bandit, the idea is for this course you need to be very comfortable with using the command line and being able to access and use a Linux machine. So Bandit is a war game on this place called Over the Wire. They have a series of challenges. We'll go here and look at them. And essentially to pass these challenges, they require you to investigate the environment and learn things about it. It's not supposed to be very difficult. It's supposed to be just making sure that you're aware and familiar with the command line because it's going to help you a lot when you are dropped onto one of my servers and you have to do things. So the instructions are all here. It's pretty easy to go through. Yeah, you can see I've already kind of looked at all of these. They're a series of levels. You need to be level 0 to get to level 1, 1 to get to level 2, 2 to level 3, and so on. Cool. And then the way we're going to track you on this is pretty cool. There's a site called WeChawl that actually keeps track of your progress on multiple of these war games. So the Bandit Challenge being one, there's actually a ton of sites. So this is actually a great way. The reason why I'm having you do this is A, it's easy to track you, and B, so that you can see these lists of resources to go and explore and further your security knowledge. So everything's here, it's pretty straightforward. Keep tracking your README. So in your README is the thing that you'll submit. It'll have your WeChawl name and it will have how you broke each level. So keep track as you're going so that we can see that yes, you did this and you didn't just copy everything from your friend. Questions on this? Cool. This is fun. This should be pretty straightforward. The goal is not to be super difficult. If it's super difficult because you don't know how to use the command line, then you should spend time to study so it becomes easy. All right, the third part, backdoor web server written in C. So the idea behind this, the idea here is two parts. A, to get used to writing C code because you're going to be looking at a lot of C code in this course. And also to get you working with sockets and socket programming. So if you haven't done any network programming, this will be a good introduction to that. The idea is you're going to create a minimal HTTP 1.1 server based on the RFC. So the third goal of this project is so that you can actually learn how to read RFCs and understand them, about what they do and what it means and what the protocol, what you actually have to implement as part of a client. So this is another cool part that I really like. And you can't use any libraries except for the C standard library. So everything's in C. There's no any other garbage, just straight C. So the idea is you're going to create this backdoor program that's called normal web server. It's going to run, listen on a given port. Basically, most requests, it'll just give a 404 HTTP response code. How do you know what a 404 HTTP response code means? You read the RFC and see exactly what that means, and that should tell you what you need to do. Let's see. Oh, and the backdoor is if somebody makes a request to a URL of /exec/any command, then what your backdoor web server will do is we'll take that command, pass it to the system libc function, which the argument you can read about there, and we'll return the output from that. So the idea here is you can think of this like, let's say you hack into and break into somebody's server, you want to give yourself a persistent backdoor, you install a web server there that looks like it's benign, it accepts port 80 requests, but actually it has this backdoor functionality to give you access back to this machine whenever you want. So there's some examples here. The important part here is it's got to work on Ubuntu 16.04, so this is going to be our standard platform for all assignments and everything throughout this course. So it's got to work on Ubuntu 16.04. If you have, you'll need to set up a 64-bit, so you may need to set up a virtual machine to get this so that you can do your development there. I don't know, random excuses of, oh, but it works on my Windows machine, that's not a good excuse, right? So it's got to work. It's like, it's like the works on my machine like designation on a bug, right? The developer says like, oh yeah, it definitely works on my machine, but it's actually broken on the server in production. So really it's broken, right? So you've got to actually fix it. And the best way to do that is to make sure the environment you're running locally that you're developing on is the same as the remote environment. There's some resources here. Feel free to share each other resources about good tutorials or whatever about how to do network programming in C. For this, you'll submit your source code along with a makefile. I'll add more stuff about a makefile here and a README. And there'll be a submission server that's not quite up yet, but I don't think any of you is going to finish in 2 days. So I will, in the next 2 days, I'll have the submission server up and running, and you'll be able to submit your code and get immediate feedback as to your score, what test cases you didn't pass, all that jazz. Questions? Don't forget your password to the site. Although maybe I'll have one of the TAs add some functionality for that, so I don't have to do it by hand. Yes, in the back. What was that? No. Individual assignments. Yeah, gotta do this stuff by yourself. Yeah.
Multiple submissions allowed?
Yes. I don't know how many yet. We'll see. I keep it usually, because I don't want you to use the site as an oracle. It shouldn't be like, oh, change one letter and then resubmit and then see that it fails and then change another thing and then resubmit, right? The point is to allow you to checkpoint yourself as you're going along. But I've never had people like scrambling for problems, but it also does take some resources to process all these. So when all of you start submitting, it gets kind of buried. But so yes, there will be a limit. Anyways, we'll deal with that. It's never a problem, so don't worry about it. Yeah.
What do you think is a reasonable timeline to say we start working tonight?
Ooh, well, it depends. I mean, a reasonable timeline to finish. So should you start working tonight? Yes. So it's due, I guess I didn't say, due the 23rd. So what's that, like slightly less than 2 weeks? I learned this trick in the past. If I did it in 2 weeks, nobody would come to the class in 2 weeks because you all be at home doing the assignment instead of coming to class. So yes, so right before 2 weeks. You should definitely start now, like especially getting started on Bandit is important just so you can feel the flavor of the levels and the challenges, solve a few, and then you can see, oh, okay, I could go back and do like a half hour a day and this will be done in, I don't know, 3 days or something. The back door really depends on you more than anything. If you start today, I think you can finish this in a week or something. So, but I want to give, I think you can still add courses and stuff, so I want to give enough time in case people have that. So, yes, question?
Hey.
Yes.
I've already done Bandit.
Good, then that's fine. Then,
Do I still need to go do the tracking thing, or I just do the document that I did when I created when I did it?
send an email to the communication list. We can talk about that offline. Anything else? It's on here. Yes.
Is it piecemeal submission or everything needs to be submitted at once? Like
Each part is individual, so you can submit each part on its own. Yes.
I missed the link that you in the first class you said about the Google chat, the Google.
The Google group, there's a link right here on the course mailing list. It's on the syllabus and it's on the main webpage. So, what's the main page? Oh, it's my website. You can just go to my website, adamdupay.com, and then you can go to teaching and find the classes from there. Or there's now, I just added it before class, there's a link to the syllabus on the my ASU. And so you should be able to get everything and find everything from here. All right, cool. Let's talk about ethics. Try this again. Does this actually make a difference? No, I don't think so. Does it? Hello? Testing. It's gonna do it. Testing. No? Oh, it's off. That helps. Testing. Yeah, that works. Okay. I'm gonna use this thing. Okay. So that's probably not what you want to see. I don't think it's going to work. See, it's showing me the regular slideshow, and it's showing you guys the presenter view. Unless I changed the wrong one. Sweet. Thanks. See? Look at that. All right. All right. So ethics. Well, ethics. So we've talked about famous hacking incidents and the people who perpetrated them on Monday, and we've seen that it often does not end well for our nefarious hackers. They frequently find themselves in jail. So while ethics itself is a huge, philosophical thing that we can talk about, mainly what I'm concerned about is because I do not want any of you to end up in jail, especially because of me or things that I teach you. Because, like Adam said, it's okay is not a good defense. So this is something, so avoid jail. We want to, and what this really means is we want to make sure that we are ethical in our testing of security vulnerabilities. We want to make sure we don't accidentally or purposely do anything illegal. So it's actually kind of easy. Just don't do anything that's against the law, right? Don't do anything against the law, you won't go to jail. What does this actually mean in a hacking context? Are there any lawyers in here first? I had that last year, that was fun.
Pretty
Yes.
much don't hack a system you're not authorized to be on.
Yeah, how do you know if you're authorized? So don't hack a system if you're not authorized. How do you know if you're authorized or not?
You don't have, if you're not granted explicit permission to be on there.
Yeah, so
Most of the time, they would announce that they want to be penetrated, and if you find any bugs, so there's a bug bounty program on your website, and or other websites like HackerRank, and so if there is any bug bounty, so you are free to do penetration testing, and yeah, if you get any bug, so you will get paid. Otherwise, you're going to jail.
yeah, so the question is so it's all about authorized, right? So if I can basically hack and try to break into my own laptop, right? I own a laptop, I own the software that's running on there. I can try to find and exploit security vulnerabilities against my laptop. Let's say I find some remote code execution vulnerability against MacBooks, and now when I launch that at you and your computer or that computer, right? That's when then that's illegal because I'm getting unauthorized access. If I tell you about this and you say, hey, that's super cool, run that against my machine, now you've actually authorized me to do that, right? So this is really the main thing is don't hack into a system that you do not have permission. And fundamentally, I think the other way to think about this is don't even attempt to find vulnerabilities in systems that you don't have permission. So it's incredibly tempting. I know especially when you first get your first taste of security knowledge, to want to then go out and hack everything and find bugs everywhere. And bugs are everywhere, absolutely. So there's bugs out there, you can go out and find them today. But if you don't have permission to do that, absolutely 100% do not do that. As one of the students already mentioned, as we'll talk about, there's a number of bug bounty programs and companies that actually give you access and allow you, authorize you, hey, feel free to hack, find vulnerabilities against our system, and from there you can go to town on those as long as you follow their terms of service. So some of the things that you can do, you can always download source code from onto a system or server that you control, assuming it's open source. If you stole the source code in the first place, then you have problems. But if you download source code that you control, you could look at that source code, run it locally, find bugs in those programs running on your system. That's 100% fine. So, and we definitely need to practice. I mean, this is one of those things like you get good at security by doing it over and over again. So you want to practice your vulnerability analysis, your exploit development skills, download stuff. Bug bounty programs are a great way. So there's a number of websites and resources out there. You can go, and a lot of actually companies themselves have bug bounty programs where they say, hey, you find that we give you permission to pen test our systems. If you find something, tell us and we'll give you money, which is kind of awesome. The third way is actually really fun, and one way I like is become an academic. So this is kind of the third way to be able to test systems. And the idea is, so oftentimes in our research, we want to answer a question like, how common are, let's say to cite a recent thing, how common are email header injection vulnerabilities on the web? Right? That's an interesting question because it's, well, is it a huge problem? Is it not a big problem? What's the implications there? And so to answer that research question, we developed a system that went out and crawled and scanned the web looking for email header injections and actually triggered and tried to get some emails sent. And so, you know, we're not necessarily, so we have to balance the scientific benefit versus the ethical benefit. And the nice thing is we have the backing of the university and the lawyers at the university to go to bat for us if anybody ever has a problem with that. But it definitely is something that we really consider the ethical considerations here before we do this. So that was actually a super fun study. We do kind of studies like this all the time of searching for vulnerable stuff for scientific purposes. So that's kind of the third part. So bug bounty programs, there's actually a lot of them. Some, actually I guess I should. Some will give you money, or most, but some will just give you fame, which is still pretty cool. The key is understanding that yes, you have permission and understanding what is in scope. So that's actually, so just because I have told you here that Facebook has a bug bounty program, that doesn't mean you have free reign to go do whatever you want to do on Facebook. You have to actually go to their bug bounty program, read, understand the terms of service there so you can make sure you're doing it ethically. And this actually is a really good incident here. So a security researcher found a vulnerability in Facebook that allowed them to post on anybody's wall. Is that a vulnerability? Why?
Because you can post on fake information about somebody else.
Yeah, so normally, so it's all about what is, what's the normal functionality of Facebook, right? The normal functionality of Facebook, you have to be friends to be able to post on somebody's wall. So this security researcher found this out, that they could post on anybody's wall. And they actually reported it to the Facebook security team. Unfortunately, there was a bit of a communication breakdown. I believe the researcher was Turkish, didn't speak English very well, and the vulnerability description wasn't well described. I think it just said something like you can post on people's walls, and so it wasn't really clear what the problem was. On Facebook's side, but it's a double-edged sword. So Facebook's side, they really didn't follow up on it, and were kind of dismissive, and were saying it's not a problem. And so this researcher, to actually get the attention of them to fix the problem, posted on Mark Zuckerberg's wall, and writing about, hey, I found this vulnerability, and they didn't post on anybody's wall. And you can imagine that was, that got fixed within like 2 hours, that bug. And so the researcher, you know, then went, hey, well, I reported this bug to you guys, I should get my bounty. And Facebook was like, well, but our policy specifically says, so they actually, Facebook is super cool. They give you access to a completely different test network than the normal Facebook network. Like not in terms of network, but in terms of social network. So you can create as many fake accounts as you want, friend them with each other, so you can have your own little playground to play in, so you don't actually demonstrate vulnerabilities on the real website. And they specifically say in there, do not, you know, if it's possible to do it in our test bed, in our playground, then do it there and show us. Don't do it on the actual Facebook website, otherwise you're violating the terms of our bug bounty program. So they actually didn't, they said that this researcher was ineligible for the bounty. So, you know, this is, you know, an instance where the researcher from a good place wants to get the problem fixed, so escalates it, but in the process is actually exploiting it, you know, to raise awareness here. So it's kind of a tricky situation. So yeah, here's the, you can see the post here. This screenshot is from this researcher. Dear Mark Zuckerberg, first, sorry for breaking your privacy and post to your wall. I had no other choice to make after all the reports I sent to Facebook team. And then it's like a whole, oh, I guess it wasn't a Turkish researcher. Yeah.
I was gonna say, even though you get the bounty, all he needs to do is put Zap on his resume.
That is true, yes. So, yeah, I don't know what happened to this person. If anybody wants to go do a history report and do a study and figure out what they did afterwards, but yeah, that would be a pretty good resume booster for sure. Oh yeah, you can see the whole thing here, and so you can see like it was a big, you know, it caused a big problem. So, let's kind of put yourself maybe in this person's shoes or some other person's shoes. You spend a lot of time looking at, let's say, a piece of software or something, or a website. You find a vulnerability. What do you do after that point? What was it?
I would say file a bug on it,
File a bug on it? With who?
the service that which you're, if they have it available.
With the service, so maybe file a bug on it. What else? What are some other options? That's it? It's your only option? Yeah. Tell the world about it? So, like, in what way? Just stand outside shouting about it?
Making some blogs so that everybody will know that there is a.
Yeah, you could write a blog post about it and post a blog post about it. Yeah.
Just to evaluate the implications of the vulnerability first.
Why?
I mean, if it's something that's related to like national security, then you need to take a different approach than if it was just like found something in GoDaddy and like some website admin.
Right, so that's an interesting case, right? Like being able to post on somebody's wall versus, let's say, you found a bug in some nuclear reactor software or something like that, right? So that's interesting. So like understanding the context of the vulnerability itself. What else? Yeah.
Even though we have good intentions to understand the complications of that, but it can in turn be hacking or just if it is something pertaining to national security, and if you go into the bug and explore what it is, you get to know some information, and that might be violating someone's privacy. So, and I just
Yes, but let's say you shouldn't have done that in the first place. So let's say we found the bug completely ethically. So we didn't violate any privacy, we did it. We had 100% rights to find it.
we can report to the information security officer of the company.
Right, so we can report it maybe, so we can file a bug report, try to find the security contact of the company. What else? You guys are all too nice. What else could you do? What was that? Wait just a second. Sell it to who? To me? I'm not buying. To the competitors. Ooh, that's a good way of thinking. Yeah, so you can maybe sell this bug to the competitors, or try to at least. What else? Who else would buy vulnerabilities? Yeah.
FBI, maybe I've seen they buying 0-day exploits on Apple phones.
Yeah, so you may sell it to either directly to a government agency or to a security company that is known to then sell them to government agencies. You could go even worse than that. So if you find something in a nuclear reactor, you could sell it on the black market to whoever wants to pay you in Bitcoins, and you don't know who they are. Maybe they're a malicious state actor or a terrorist organization or whatever, but hey, you don't know. They're just like an anonymous person who wants to buy your information. Yeah.
So this is all what you could do versus what you should do, right?
Yes, yes. We're just talking about what you could do. What you could do. A discussion first about possibilities, and then we'll talk about pros and cons. Yeah. Yeah.
Write a white paper. This is.
Yeah, that's the academic approach. You write a paper. Actually, the way you do it is you really find one vulnerability, then you write a tool that can find more of those, then you run that, find more, and then you write a paper about it. So that's how that goes. What else? What about doing nothing? You do nothing, right? Inaction is an action. It's an option. You just wait. Maybe the market's not right. Maybe you're not going to get money. Maybe you may need it in the future. You maybe pull it out. And so, okay, so these are any other possibilities of what you could do? Yeah.
Maybe we can use it to, in the future, change this vulnerability to other vulnerabilities to gain more access, and so we can get more popularity. Instead of just getting access to just one computer, maybe, for example, 2 years later, somebody finds something like, for example, SSR vulnerability, so you can scan the internal network and get access to others.
Yeah, so it could be, and it kind of depends, so it depends on exactly what it is, but if you were let's say you're trying to make an end-to-end exploit, let's say from a browser that lets you pop out of the browser and exploit the browser, escape the sandbox, and get access to the system, you may need multiple vulnerabilities together, so you actually may save it for later in that sense, with the intention to combine it with other things later. Cool. All right, that's pretty good. So what should you do, or what? So I guess that's I think a loaded question. So what are some of the pros and cons? Let's think about some scenarios. So let's say the tell the world approach. So let's write a blog post about it. So what are the pros and cons there?
Fame.
What was that?
Fame.
Fame? So is that a pro or a con?
Both.
A pro.
Yeah.
A pro. Fame in terms of yourself, personal?
Yeah, like, and professional.
Personal and professional fame? Yeah, that could be a pro.
Possible legal problems.
Possible legal problems, depending on how you maybe found out about that vulnerability, depending if you had access. I think you can be reasonably certain if you, like, let's say found something in an open source piece of software that you have on your system, you would be, I'm not aware of any cases where that would have legal ramifications.
Someone
Yeah.
might not have the same intentions like you, and someone who read that, he can go and exploit that.
Yeah, so on the con side, right, not only, so telling the world means you're telling literally everyone, right? You're not just telling the good guys, or the good people, you're telling also the bad people. Any other thoughts? How quickly do you think it's fixed?
Depends on your page rank.
What was that?
Depends on your page rank.
Depends on your page rank. Let's say it's actually like a big deal. It ends up being a pretty big deal. Everything?
Probably gets fixed pretty quickly if you just blurt it out, because then they know that it's anybody's vulnerable, able to pick it up.
Because now the good people know that the bad people also know about this, so they know that they have to act quickly before the bad people take this and start using it for nefarious purposes, right? So yeah, so compare that to telling the company. So let's say we contact the company, let's say we're actually talking to a good company or organization that has a security email address and a way to contact them and a very nice page that's easy to search. This is not always the case, which is part of the problem, but let's say that exists. So what are the pros and cons there? Yeah.
The pros are that you probably are, if it was a bug bounty, you're probably not eligible to get it, assuming you went through the correct ways of getting it.
Yep.
The company probably wants you to do it that way because then it hasn't disclosed it to everyone else.
Yeah, so the benefit, the benefit there would be you'd be eligible for bug bounties. The company may appreciate that more because they don't have the pressure of bad people using it. Any other thoughts? Yeah.
The other place is available because maybe sometimes the company is not appreciating your, all of the hard works, and by just telling them they need patch and without, telling you anything and or even any being money.
Yeah, we actually have the con there of like, you may not even get, the company may not credit you for doing that. They may say, hey, thanks, we really appreciate that information. They just go fix it. Their software's now better, their users are safe, so you did have a good impact, right? But you may not get the visibility necessarily that you would get in a tell the world case.
They might give you a job.
What was that?
They might give you a job.
They might give you a job. Yeah, who knows? I mean, yeah, that's it's possible.
You don't have as long to, if you do it for me, if that's your first week, you don't have accountability, you no longer have as long to exploit or explore that vulnerability because, that vulnerability could lead to, say they're tied to 10 other companies, and that makes those companies vulnerable as well. Now you can affect the decision making of not just one company, but like all of the peripherals as well.
Yeah, so let's think about, so what about time to fix? Like what's the difference in the two cases we just talked about?
So usually if we report it directly to the company, they might sit on it for a while because they know that bad people don't know about it as well as good people, so maybe they might not be dominating the first.
Let's think about that for a second. So yes, I totally agree. So oftentimes the companies, for legitimate reasons often, so especially let's say you report a bug in Windows, right? Has anybody worked at Microsoft? I have, I know I have. I'm just trying to get some validation and verification in the audience, because otherwise you just think I'm making stuff up. Maybe I am, but you'll never know. So if you think about the testing matrix, so anybody done testing? So you think about a testing matrix is like all the different possible combinations you need to test of your software. So whenever they make any patch or change to Windows, they have to ensure that it runs on every chip, every hardware combination, insane amounts of testing go into testing Windows changes. And so, they may say, hey, because you as a researcher, you want it to get fixed as soon as possible. The company also wants to make sure that their change doesn't affect and break people's software, right? So you have this tension between the company and the researcher. Although, I guess the other thing is, so the other thing he said is because, I think I'm going to paraphrase it because I don't remember exactly. I wanted to steal it, but I ended up talking instead. He said that the company doesn't know. Oh, there's not this pressure that the bad guys know about it. But is that true?
Not really. Because they may know it.
They may know it and we don't know it, right? So yeah, this is actually one of the really important things to think about when you're a security person is that you're probably not, you find something cool, that's super cool, you're probably not that special where you're the only person on earth who's ever going to find this. And so this bug could actually have already been exploited by people, right? So this is actually what drives a lot of the security researchers. If your goal is to limit harm and try to improve the security of people, then you want that fixed as soon as possible, right? Because you found it. That means it's likely somebody else had found it in the past and they may already be using it maliciously. If you don't have any evidence of that, then you have a problem, right? So that's why there's this big kind of discussion in terms of disclosure about what to do. So the tell the world is usually called full disclosure. Tell the company or group or organization responsible has a really good marketing name called responsible disclosure. So this is actually a good case of PR in coming up with a good, because why were you not responsible in disclosing things? And so, other things that we said, so no disclosure, you sell the information to there's a couple different ways you can go. Some are more ethically gray than others. So for some, so there's is it CDI is the company that by HP, anyways, they will buy exploits for not a ton of money, but a good amount of money, and then what they do is then they use that in their antivirus systems that are running in corporate networks to say, hey, we're actually defending against 0 days, completely unknown attacks, right? And then once you sell it to them, they'll push that out to all their customers, and then they'll work with the vendors to get it fixed. But now they can say that they've guaranteed that their customers are not going to be attacked by this in the meantime. So you can do that, or another way is, you can sell it to governments, malicious governments, terrorist organizations. You could sell it for whatever kind of money, with the understanding that and mainly what they're buying is not only the exploit, but also your guarantee that you're not going to sell this, you're not going to release the details, right? So they're kind of paying for your silence, and that's what they want there. So what do you think is what do you guys think is, personally, what do you think is the right thing to do? It's just because it has the word responsible in it. If I took that out, would it be different?
Maximize utility and limit risk.
So I think the important thing is that I think it's really a personal decision. I definitely, I would say black market would definitely be for me personally, ethically not okay with. I understand that that's how some people in some organizations make money, and I guess you just have to be fine with that, I don't know, it kind of goes back a little bit to the fame or at least credit or whatever. It's you spent all this time to find this, and now you just want to sell it to the highest bidder, or tell people how cool you are and fix the world in the process. But I think there are important differences between full disclosure and responsible disclosure. So those two, I definitely feel that that's more of a personal decision of what you are comfortable with. There are really good reasons to do full disclosure sometimes, and so I kind of want you to think about this as like this is a very murky area, and it's still being debated by security people. There's not a this is the one way to go. And so personally, I kind of believe like responsible disclosure in the sense that you first work with the company, but with the understanding and the expectation set up front that you will release this at some point. This information will become public because you want to make sure more people know about it. So the other thing that people do is they'll do like a responsible disclosure with a deadline and say, hey, I'm reporting this to you on this date. 90 days from now, I am going to release the details about this vulnerability. And that's what I'm going to do. And if your patch isn't ready, then I'm sorry, but I've given you 90 days, and there could be people already affected by this. So it's kind of a personal decision. So would you hire a hacker? So we talked about that a little bit. So let's think of the malicious ones. Think about the people that we talked about a little bit on Monday. So like the really black hat malicious hackers who were breaking into computer systems. They get caught, they go to jail for 5 years, then they get out. Would you hire them?
Depends.
Depends on what?
Because I've heard stories that FBI and CIA are always hiring hackers.
Okay, well let's say you're the FBI or CIA. Would you hire them?
Well, because if they're good enough to know what they did, they may be able to help prevent.
Okay. Yeah.
Or like, are their skills still relevant to the current state?
That's a good one. I've never heard that one, but that's really good. Let's say it's less. They weren't in jail for 5 years. That's actually a long time.
With no computer access.
Yeah, with no computer access and all that stuff. Yeah, that's super funny. Yes, let's say they're still super relevant. That's a good one.
It depends on like the maliciousness, I think. You know, again, it goes back to like ethically gray. You know, for example, when that guy posted to Mark Zuckerberg's wall, there was some chatter about like, is this guy going to be prosecuted? And Facebook may have had that within their legal domain to do since he didn't follow the policies. But in that instance, definitely hire that guy.
I guess the key question is we didn't talk about is hiring. So the depends is I definitely agree. It also depends on for what job, right? If we're talking about like flipping burgers. Who cares if they're a hacker? Like, what are they gonna do? But if it's, let's say, to defend your company, right? To be the CISO, like the Chief Information Security Officer, whose job it is to come up with the policies to defend the organization. Or even lower, I mean, kind of like a blue team or an incidents response. So would you hire a person for a defensive position if they were a... So we have some people say yes, they definitely know the area, they know what the bad guys know, they're one of the, I'd say they're some of the best hackers in the world, but they got caught, so like how good could they be? Yeah.
Like the trust is the main factor, right? That you want to keep your company.
So why do you need to trust them?
Because you're not sure if they're doing the right thing when you pay them, right?
Yeah, so you're literally letting them into your organization, have access to everything in your organization. You're giving them the keys to their kingdom. Are they going to be there forever? What happens if something happens and you have to fire them? Right? Are they going to go quietly, or are they going to release sewage all over the place? Right? Yeah.
Maybe we can keep monitoring them and keep them in check.
So you want to like super monitor and double check them? So like hire somebody else to watch them. That's good. It does depend on the role. You can think of like a pen testing or a red team, more an attack-oriented side. These people could be perfect for that. So I think that this is a good discussion, and it really is like an open problem, and like we said, it really depends on a lot of variables. It depends on the person, and I think that was a good point. It boils down to trust, really, is you want somebody who can find problems before the bad guys do, and these people are skillful and motivated. But the downside is you don't want to hire an arsonist as the fire chief. Right? So, and some, these, especially some of the people in the examples here, and maybe it's an overgeneralization, but definitely some of them have horrible personalities and are really terrible people to like work with. So that could be bad. So yeah, you really, you have to take as the hiring manager, you have to take kind of a general assessment. But hackers are hired all the time. So this does, like we said, the pros oftentimes outweigh And like we said, the main problem is how do you fire these people, right? Very difficult because you, this person here is just like stealing credit card numbers. I'm like, okay. So what we're going to be looking at mainly here is, what we're talking about is penetration testing. So penetration testing is very broad. And this is actually, so we're going to be looking mainly at vulnerability analysis. So how to identify vulnerabilities in a system. We'll also look at exploits, so writing exploits for that. Penetration testing more generally is when a company will usually hire somebody outside the company and say, okay, we want you to act like a hacker and try to break into our systems, digitally usually, although there are cases of where physical pen tests occur. And so, and so the idea is, so what's the use here? Why would a company do this? Like, do you ever, I don't know, I'm trying to think of like a personal example. Do you ever hire somebody to try to break into your house to see how good your security system is? Do you hire people to chase you to see how fast you can run?
You don't have as much to protect as they do.
You don't have as much to protect as they do? That's probably true. And you probably don't have enough money to protect also as they do. Yeah. Maybe rich people do that. I don't know. Yeah.
Because these are the people you actually like pay them to find the resources, but hackers, whereas they don't have the same intentions as these do. So they can, when they find when they find the same vulnerability, they might exploit it, but these people will report to you and you can change it.
Yeah, their job is literally to tell you the vulnerability. So you get rid of all this disclosure discussion. You say, I'm hiring you. Take 2 weeks, pound on my website, find all the vulnerabilities you can, show me what you can get, and then tell me about all those. Cool. Yeah, so the idea is it's usually black box in the sense that you have the same capabilities as an attacker would. And we're not going to focus a ton on the whole security lifecycle here. We're really focusing very specifically on vulnerability analysis. And so is penetration testing useful? So you are in charge of securing organizations, you hire a company, you give them $200,000, they get 3 weeks, they come back with a report. Is that useful? Yeah.
It's useful when the company has some, programs for penetration testing, not just one penetration testing, because it should be a regular process.
Why?
That because the developers all the time are trying to develop the new codes, and also there are new vulnerabilities that could be found during this time. And so they should analyze all of them regularly, and so
yeah, so you can think of it as like a pen test is kind of like a snapshot in time of, hey, this is what we could find on this date, right? But systems, organizations are constantly in motion, patches are being deployed, systems are being upgraded, hopefully they're fixing all of these things that you found, but who's to say they actually did, right? So oftentimes that's why so when you do a pen test, usually you'll do one and then maybe a follow-up after a few months when they claim they fixed that, just to verify that they've actually fixed those problems. So yeah, it's a downside in the sense that it's a one-shot deal. And it's only what those people can find at that one time, and who knows what happens a month or 2 months ago. Was it useful?
That depends on, how much money you have to pay versus what's your threat of attack, what's your, like if you have the resources to do it and you can, you have a team to move forward from the results, then it can be useful. If you don't have the money to do it, then.
Yeah, so it's interesting. So some things like for PCI compliance, which is the organization that regulates, it's like a self-regulated industry of credit card people. So if you want to process credit cards, you have to get certified as PCI compliance. One of the steps is to have an annual pen test and to fix the problems in those pen tests. So I've done a few pen testing gigs back when I was doing my PhD. They're super fun because you always find stuff, like because you get free reign to do whatever you want. Yeah, you always find, we always were able to find stuff and find different bugs, and so it's always really fun. And then you have to actually develop the exploit to show them, right? You don't just want to say, hey, I think there's a bug here. So for instance, this was a credit card processing company. We found out they had one of these classic problems where you would get your monthly report, and we had a fake company, so we'd log in and get our monthly report. The monthly report was some number.pdf, right? And we were like, that maybe looks like an auto-incrementing ID. So we tried various numbers in the range plus minus 100, and we started getting other PDFs from other companies. So at that point, we were like, we need to show them how bad this is. So we wrote a crawler to download every single thing we possibly could. And so we had all the credit card processing of all the companies that they had. So this was, super sensitive information that we were able to steal. And to demonstrate to them, hey, look, this is how, this is what an attacker could do. Yeah.
I have a question. We are talking about ethics, and so I have been in a situation during the penetration testing. We need to reporting all the stuff that we found. But the problem is that if consider we are, for example, working on a two-step authentication system, and this system is implemented in the core of a banking system, or even in a telecommunication system. And using that, you can get the authentication password of a lot of users, and so you can change their passwords. And so the problem is in that component, which is a third-party component, and it's not related directly to the company. And okay, in this situation, when we are just reporting to that company may just have all of this information as considered as confidential information and don't disclose that. What should we do in this case?
Yeah, I think that's up to probably your pen testing agreement with the company. So you probably want to cover yourself in advance by having a clause saying like, hey, if we find any bugs in any third-party components, we'll release those separately a month or 2 months from now, or do responsible disclosure with that company. If you don't have that in place, then it's really all about your relationship with that company, because, I don't know exactly how, I'm not a lawyer again, but I think like it's kind of like, it is a consulting gig, right? They're paying you to perform a service, and so they kind of own all the stuff that you found during that thing, right? But
so at the first step, you should be responsive to the component director and developer.
yes.
Or
I would work with the person that hired you first. That's who I'd talk to say, hey, we found this thing in the third-party component. Because you have to be very careful. So we actually found that one of their credit card processing machines had like a IPMP, which is like this server config protocol open with a default username password. So I could have completely like installed my own kernel on that machine, and but as soon as I found that, I was like, oh god, this is awesome. And I started thinking about all the crazy things I could do, but then I calmed down and talked to people, and they were like, don't do that, we're fine. Just tell us what you found. We're totally fine. We believe you. So yeah, it's all about, like was mentioned, managing risk and balancing risk. So cool. So in summary, proceed ethically. So this is what I'm not only expecting but mandating of all of you in this course. Only attempt to find vulnerabilities in web applications or other applications that either you control or have permission. Jail is a possibility, and it's also against the ASU computer misuse policy. So definitely don't.
I think the bullets were in the wrong order.
You think that being
ASU policy first, jail second?
Well, maybe you can still finish your degree even if you're in jail if you didn't break the ASU policy. I'm not advising. I don't know how that works. You could do remote classes, maybe. So where we're going to start out, on network security. So we're going to look specifically at all the ways we can break various network protocols. And it's actually incredibly important because many applications don't just process, our input directly from our terminal or our console or our GUI, right? Nowadays, many applications talk over the network. There are lots of protocols. When you talk about the web, you can't really talk about and understand the web if you don't understand TCP, IP, all that kind of stuff. So we are going to go through networking, and so it's going to seem like a networking course for a couple weeks, but that's because we need to lay the groundwork so we're all on the same page for all the networking protocols, how they all work, and then we get to talk about how we can break them, because this is actually one of the things you do as part of pen testing is you go to an organization and you plug into their wall and see what you can do, right? Can you get, so if a bad guy came in and just plugged into the Ethernet connection, can they get access to the database, right? Can they sniff on developer traffic? Could they steal emails? And so if you don't know how to do all of this, we're only teaching you a very limited part of insecurity here. So the IP suite, so the networking stack, basically, we're going to be looking at TCP/IP. The idea is, so has everyone heard of the OSI network models? How many? So 7, what are they? Or is it 5, 7? 7? Good, that was the best. So what are they, starting from the bottom? Physical. Something. Link. Transport. Application. All right, it's fine. It doesn't really matter. Yeah, we have physical links, internet, transport, application. I like to think about the 5 model. And yeah, so here's our nice stack. We have the physical layer, which is the actual how bits get transmitted over wires. I'm not an electrical engineer or anything like that. I just assume it's magic that works. The link layer, as we'll talk about, this is where now we get hardware components talking to each other. We have the IP layer, the transport layer, and then applications on top of it. So I like more of a simplified model like this because it maps very closely to the protocols we're going to talk about. So we'll talk about, so basically, I mean, the way we're going to go about this is, so remember when I said like security is all about breaking down abstraction layers and understanding exactly how things work, and that's what we're going to do here is understand basically from the physical layer up about our hardware interfaces, IP, ICMP, TCP, UDP, and then we'll talk about probably some protocols at a later point. Cool. So IP addresses, the way to think about IP addresses, if you've never done networking, IP addresses are like an address. So the idea is you have some machines on a network. We have 2 nodes on our network. These nodes need to talk to each other, but they need to know who to talk to. And in this course, we're going to be focused on IP version 4 because it's still one of the most popular, it still is the default standard protocol. Hopefully, I should be able to give you enough background and insight into IPv4 that you can then go learn, read the specs on IPv6, and you can become an expert on your own time. So, the whole idea with IPv4 is it's a 32, so your address is a 32-bit integer. Wait, 32-bit number. And you'll mainly see these in terms of this decimal dotted notation. So this is basically, so you think 32 bits means 4 bytes. So the first byte is 0 to 255, 0 to 255, 0 to 255, 0 to 255. So this is the standard, kind of when you look at a raw IP address, this is mainly what we look at. The classes are not very important. I'm going to skip these. It used to be you had certain fixed class sizes where like a class A network could have, about what's that, 16 million hosts on it. But they realized, hey, that's a terrible idea because one organization doesn't necessarily need 16 million addresses. And so they invented a way called CIDR, classless interdomain routing. The idea is we need more. So basically you can put because the idea is with the internet, you need to know basically not only the IP address, but you need to know what network, like where in the large scheme of things is this host located. So here, we'll look at this. It'll be very clear. So the idea is your address, you'll be able to place the host ID and the network ID boundary with this. We'll see in a second. It's pretty easy. So IP is basically how we can get a piece of information from one machine on the network to another. And it's actually pretty terrible when you think about it. is connectionless, unreliable, best effort. It has no delivery, integrity, ordering, non-duplication, or bandwidth guarantees. It guarantees you almost nothing except that I will try real hard to get this packet to that IP address. And yet everything still works. But actually this is, a really good point, and when you think about the design of networks, what's nice is now when we think about that layers we just looked at, right? If the IP layer doesn't guarantee all of this, then other layers above that can, and not everybody needs all of these guarantees. So it actually, what seems like kind of a horror, it's like, why would you build your network on quicksand, right? You don't know, you want to talk to somebody, you send them a message, the letter could go away, anything could happen, but it actually is pretty nice. So basic idea, if you have IP addresses on a network, you should be able to send IP datagrams or packets from one node on that network to the other. Good. Okay, great. So again, we're talking about RFCs. So this is the RFC. You can read exactly what every single bit inside of an IP packet means. We'll talk about kind of some of the more important ones. So the way to read this, so the idea is, so just like if you're sending a letter to somebody, right? What do you have to do if you want to send a letter? Do you just write a letter and then just throw it in the mailbox? What do you have to do? You have to write the address. You have to usually put it in an envelope, right? A, so that the mailman or mail lady can't just see it, but also so that you can write where it's going to, right? Where is this letter? Where's the address that this is going to? You also write where did this address come from, so you put your address on there as well. And what else do you put on there? You gotta pay for it, right? So yeah. So you gotta think about this as like, so these are gonna be some headers of an IP packet that tell all the switches along the way, hey, this is where it came from, this is where it's going, this is any other metadata. You can't put stamps on here yet, but maybe in the future. So first thing, so the first 4 bits, so these are bits, so bits 0 through 31. I'm just gonna go through this and talk about some interesting ones. Okay, cool. So we first have, we have versions, which would be 4, right? So this is important because if you want to upgrade a version number at any point, this way immediately somebody that's parsing this packet can know that this is version 4 versus version 6. The length, so the length is important so that that we know how many bytes or how many bits to expect. Identifiers we'll talk about in a second, fragment offset. A time to live, so this is an important value as we'll see. We don't want packets to just float around forever among networks. So if there's ever a networking loop where A sends to B, B sends to C, C sends to A, that packet would just keep looping there forever. So the idea is this time to live field gets decremented by every packet along the way, so that way when it drops to 0, they stop sending that packet. So it's a super important, and it actually will come up really handy in what we're going to do in some security stuff. Protocols, this is kind of interesting. It's actually not that interesting. Okay, other important things, sorry. Source IP address, destination IP address, right? So this makes 100% sense when we talked about an IP address is a 32-bit integer. Here are where the 32 bits are located inside the packet header, right? You have bits 0 through 31 and the destination IP address. So this is essentially, like on our letter, the destination address and our source address where we came from. Cool, so all of this, there's a bunch of optional fields that can exist, and then there'll be the actual data. So this is what you can think of as in that letter. So this data is everything that's inside that envelope. Yes, that was the word. Great. Okay, so this is more details about this. I'm gonna skip over this because you can, important thing here is the max size. So it's actually interesting that's the wrong thing. It's actually interesting if you've never thought about of why this is. So the total length, so here we have 16 bits here to describe the length of an IP datagram. And that means that the maximum length of an IP packet can be 65,000 bytes. So directly follows from 16 bits to describe the number of bytes. Cool. ID, so ID is important. It's going to uniquely identify this specific datagram packet that we're sending. Various flags that are used at IP flags, the main one is used for fragmentation, which we'll talk about in a second. The time to live. The protocol, okay, it is interesting because it actually tells you about what protocol is at the other layer. So it's kind of a weird abstraction breaking thing, because why would IP packets care about what kind of data is underneath? Checksum, so a checksum is important because you want to make sure that no bits were flipped or changed in your transmission. So this is 16 bits that allows the switch to calculate and say, yes, everything looks like it's correct. Addresses, okay. Options, yeah, crazy. So what's really interesting when you read these specs is you can see all these weird options that they had historically. So security bits in there, so actually kind of similar to our, what we talked about with maybe paying with stamps or something. So like a bit that says this packet is secure so that the switches could decide not to send that out anywhere. A really interesting one was recording the route. So each router would record its IP address in the packet when the packet went along, which seems ridiculous, but why would you want something like that?
So you know where it's been.
Yeah, so you know it's been, or so you can debug the network, because they had to add these things back when stuff didn't work. And so you need, when you have to just send a packet on a unreliable, no guarantee network, and it doesn't get to the other side, what happened, right? Timestamps, so you can put timestamps on there. Interesting one was source route. So the source machine could actually specify what route should these packets take, which is kind of crazy. And there's a lot of other options. They're pretty fun. Maybe one of these, that'd probably make a good homework assignment, is like go through and document all these crazy options. Okay, but an IP packet, right? So the IP packet was towards the bottom middle of the layers. But to even send out that packet, it actually needs to get encapsulated inside of a lower level packet, which is going to be our link layer packet, or an Ethernet frame is mainly the way we think about that. And so it's just like envelopes, right? So the frame data, what's the frame data contains the IP header plus the IP data. And the same thing will actually happen up is the first part of the IP data will be the TCP layer headers, and then the TCP data. Okay. So there's two main situations we need to deal with. One is this machine on our network? So is node A and node B, so we're node A, we want to talk to node B, we're on the same network. How does that happen? Magically throw it out there. Hope that somebody gets it.
Get switched.
Yeah, it has to go, well, it definitely has to go through a switch. So how do we know that? Okay, so let's go back to, all right, I don't like. So here we're going to use a different example, the subnet. So there's two ways of writing it. You can either write out explicitly the subnet. Here we're saying 111.10.20 is the subnet. That's the same thing as the /24. So there's just different ways of writing that. So we're going to be 20.121. This is going to be our MAC address. So this is our link layer address. So this is hardware addresses that we're probably all used to seeing. .14. So the idea is when I want to send this packet, so my IP I know, so what do I know from host A? So right before I send this packet, what do I know for certain?
Same there.
What, say it again? I know it's the same subnet, but how do I know that? Because what do I know? I know my IP address, what else do I know? Yes, and the destination address, somebody said it here. So I know my address, I know my subnet, and I know the destination address, right? I also know my hardware address. right? So I can use all that information to easily say, is this packet destined for my local address? Yes, compare the subnet of my subnet versus the destination IP address. If that's good, then that's good. But in order to send that packet, I can't just send out an IP packet. I've got to encapsulate it in the lower levels, right? So eventually we'll see the process. I will need to basically encapsulate a link layer packet from my hardware address, 0945FA072223, to B's hardware address. And I'm going to have to encapsulate that packet in there. Now, and we'll get to exactly how we go about that, because we have to, as we said, we need to discover and figure out what that hardware address is. So an Ethernet frame is much simpler. Ethernet frame is has the destination, source, and these are going to be bytes. That's the only thing that makes sense. Yeah, that's right, 6 bytes. 6 bytes destination, 6 bytes source, a type of 2 bytes, and then depending on what that type is, we'll say what's here. So type of this is an IP datagram, a type of hex 806 is going to be an ARP packet and a reverse ARP packet, which we'll see in a second. So yeah, we'll be, okay, so interesting thing here. So the maximum size of an Ethernet frame is 1500 bytes. How does this compare with IP? What was the max size of an IP datagram? Yeah, 65,000 bytes, but Ethernet can only send 1500 bytes. Seems like a problem, right? So there needs to be some kind of mechanism to deal with that. All right. So ARP. ARP is a super important protocol. Because this actually comes up this theme a lot in security. The really important protocols are the ones that communicate between abstraction layers. So the idea is we're host A, we know our IP address, we know our hardware address, we know our MAC address, we know the destination's IP address, but we don't know the destination's MAC address, right? So there needs to be some protocol, some way for us to translate from that IP address to the MAC address. And so that's what ARP is. You can think of ARP as a protocol that maps an IP address to a link layer address, so that we can actually use it in direct delivery. So before, which is actually kind of crazy when you think about it, right? Before we can even send out that packet, even to a machine on our local network, we need to do some kind of protocol and some kind of communication to figure out who has this IP address on our network. What time is this class over?
5 minutes.
I knew I couldn't ask you. I should ask them. All right, we can do this. So the idea is, right, we just talked about we're actually in a phase where we can't deliver a packet to a host because we don't know its hardware address, right? So the solution is actually pretty nice. You just shout to everyone on your network, who has this IP address? And if that person's listening, they will respond, hey, I'm this IP address and I have this hardware address. So basically it's going to broadcast to everyone, and then host B will answer and say, aha, I am this IP address on this, and this is my hardware address. A caches that response for a while, so it doesn't have to keep doing this ARP protocol. And actually what host A will do is it will send essentially its information. So instead of just shouting, who has IP address B, it says, I'm IP address A at hardware address A, who has IP address B? That way everyone else can actually cache their responses. And so that way we can minimize all this communication. So an ARP message is essentially just an Ethernet level message. And we will, all right, so we'll go over this real quick and then we'll stop. So basically, on Linux, you can run this. It's kind of fun to do this. You can run the ARP command. ARP-A shows you the ARP table of all the machines that your machine knows about. You can also use the ARP command to figure out to clear your ARP cache so that you now know nobody. So you can see that there's nobody here. We can ping from 100 to 10. And we can see this ARP, so this is a TCP dump output of the network traffic. So you can see this hardware address of A is sending the broadcast addresses all ones, so FFFFFFF. An ARP who has 192.168.1.10 tell 192.168.1.100, the switch knows that this is a broadcast MAC, so it sends that to every single port that it has access to. And so that packet will go to host C and host B. C ignores it because it is not that IP address. B then gets this request and will send a reply back that says, hey, I'm 192.168.1.10 and I'm at this hardware address. And then after that, then we can see that A is pinging B. So 192.168.1.100 is pinging 192.168.1.10 with an ICMP echo request, and it gets a reply back. And if you run arp-a on both machines, you'll see that they actually have each other's entries in their caches. So, and this is, and literally we'll plug, we don't meet Monday, do we? Sad day. It's a holiday. I mean, you can come, I won't be here. I don't know if the room's open, but we'll talk about how this leads to local area network attacks in a week.